Oh, we're on the air. I'm sorry, I didn't realize that we're already on the air. Okay, I didn't want to. I was going to make a review thing, but you've got a review. You've got a review that's even better than me. And what the one thing that sometimes reviews have come back to bite me because I've done things like people said, "Well, that question wasn't in your exam review." Well, okay, what are you responsible for? Everything in chapters 18 and 19, except for that last part on capacitance. The only thing on capacitance that you need to you need to know. Would y'all like to see this? Let me see what we got here on capacitance. Let me find the test. Okay, hold on. Let's see what we got here. Yeah. Okay, there's one capacitance question. Oh, can y'all see that? You better not be able to see that, huh? You know, jacking with me. Hey, you know what? That is the only capacitance thing on there. And we'll talk about capacitance more later on. That's it? Well, I'll be darned. Okay, so capacitance isn't that big a deal, I guess. And I've also noticed one good thing that you all did much better than the 210 students who haven't quite figured this out yet. A lot of you have really worked hard on the homework. Most of you have, so that's good. And when I look and see there's no homework done, I'm kind of like, good luck. We'll see. All right. But anyway, in fact, the only capacitance question is how do you compute the capacitance if it's this guy? Some of you are going, well, tell us what it is, Doc. All right, I'll tell you what it is. All right, I'm going to get out of here because when I turn on my ladybug, things go nuts. All right, close. All right, so let's take a look here. Turn on, and then I'm going to show you how to review for the test. All right, turn on. Come on. Hey, it's killing me. There we go. Pop up. There we are. Boing. Okay, so the one capacitance thing that you have to know, really, I mean, I'll say, and it's kind of cool because capacitors are really kind of difficult. In fact, in electrical engineering upstairs, there's a whole class on capacitance and transistors. I mean, an entire class. So we're just starting off with the rudimentary stuff where we're looking at two parallel plates and what is the capacitance in them, and Q is equal to C times V. We know that. And we also know this. We also know that, and here's the other thing. To actually find the capacitance, we do the area of the plate, okay, in meters, area in meters, times echo naught, divided by the distance between the plates. Not to, so exam review notes. That's about all I'm doing for your exam review notes, because that was the last thing we did. And some of you, in fact, I know of one student who was taking care of his wife and he couldn't make it to class on Wednesday, and that's about the only new material. And I know he's got the other stuff handled, so we're good. All right. So what's the best way to study for the exam? It's just like this. So you come in here. Here's the reading portion, Wiley plus reading. And I've broken this out. I mean, you've got access to all this stuff. Okay, and then there's all these other things in here, all these interactive physics demonstration videos and interactive solutions and video help. I mean, you've got all of these things. Did you know you had MCAT assignments in here per chapter? MCAT type questions? Some of you are going, no, I never really looked at it. You're killing me, dog. All right, so we got these electrostatic, induced Van de Graaff accessories. Here's a charge thing. How long is this? I'm not going to show this for the whole time because you guys can jump on this anytime you want.
Now let's take a look at a typical Van de Graaff generator. What we have here is a large dome that's going to collect all our charge. We have two belts inside this acrylic cylinder right here. These belts are going to rub this pulley system down at the bottom. They'll bring the charge up to the top and deposit it along the top of our dome. Let's take a look at a typical spark. We could illustrate. Ah, yes. You can see we get a nice violent spark come out of there, so it's collecting quite a lot of charge today. And if we place our aluminum pie plates on top of the Van de Graaff, turn the Van de Graaff back on, you'll note that the pie plates
That's kind of cool.
Rejected from the top of the Van de Graaff because as each one on the top picks up a charge, it then is repelled by the one right below it, which has a similar charge. We use some material we call vermiculite up at the top of our Van de Graaff. We'll now take a look at the field lines coming from the Van de Graaff because as the vermiculite leaves the Van de Graaff, it will actually follow the field lines pretty closely. Let's take a look.
This is cool.
Ah, yes. You can see that pretty well. If you were to follow those lines, you would see that those are actually pretty much close to what the field lines are coming from our Van de Graaff generator. Now let's take a look at somebody.
I'm having fun. I like this.
Now let me introduce a student named Joe Davison. Joe's right here. He's going to help us illustrate what happens to someone's hair as they hold on to the Van de Graaff when it's at potential. Joe, why don't you step up on our platform? Please put your hands on our Van de Graaff. Now if we do this right, Joe won't feel a shock, but we're going to add some potential to our Van de Graaff, and he's going to shake his head a little bit. And as the Van de Graaff builds up some potential, Joe's hair will also build up some potential as well as the rest of Joe. As he builds potential, his hair starts to separate from itself because the like charges want to escape from each other. You can see that his hair is expanding pretty nicely.
It's following the field lines too.
Pretty darn good. Joe, you have perfect hair for this. Okay. Oh, wow.
Well, that was pretty fun. See, you can do the little thing, and I like the way they tell really complicated explanations. The pie plates. Did you understand what he's saying? That the charge on top of one is equal to the positive charge on the other one, and so they repel each other, and they flip each other off. Is what was going on. Okay, and so anyway, so you've got those things, but the main thing is you go to the reading content to learn how to do the actual problems. And so here's Coulomb's law, all the way down here in 8.5. Here's Coulomb's law things. Here's an example problem. Here's like what we did in class, the Bohr model, example 3. You can work through it, step 1, step 2. I mean, if you work all the example problems out on this thing, which each chapter has, 5 or 6. Don't worry about the vector ones because homie didn't play that with you all. I like to keep 220 one-dimensional. Not that you guys are one-dimensional people. And then you can check your understanding. And it gives you the answers. I like this. It's very interactive. You can look at this and go, okay, check here, and boom. I think this is how Gerby got me. Maybe not. I don't know. I'm still going to tweet him about 2 a.m. But anyway, so that's the way you study for exam. And you guys are going to be great because I'm looking at the homework scores, and most of y'all are doing your homework pretty diligently. Okay? And so probably one things that you're worried about or might be worried about is Gauss's law. And here's what we use. For a point charge, we pretty much just shrink everything down to a point. Use E times A is equal to Q over echo naught. Okay? All right? They go into a big, long explanation, but, it's really no big deal. Charge inside the shell is 0. Charge on the outside, positive coming out this way. Pretty much what we do is we try and shrink it down to a single point type thing. And everything's good. Electric field inside a parallel plate capacitor. Oh, this is kind of nice. A Gaussian surface contains a single charge within it, and as a result, an electric flux passes through the surface. Suppose that the charge is then moved to another spot within. What does the flux does the flux change? The answer is no. Does not change. All right, so what about this guy? The drawing shows this is kind of fun. I mean, but you can do these things. You can do these things, and if you work through those, if you just go through those 2 chapters that way. Now the next test will probably be over 3 chapters, but you just have these 2 chapters. If you go through those things, you actually just calmly go through it. Spend about an hour and a half on each chapter. Boom. Then go to bed. Get up and do and take the exam. You'll be great. All right. Okay. That's it. That's all I'm going to talk to you about. That's how you review for the exam. And of course, you go to Gage's SI. I think that's tonight. I'm not sure. All right, out here.